So, good morning, guys. We're going to go start with chemical reactions today. This is chapter 8. You've done some work on it already on your own. Chemical reactions. Okay, most of you have taken some notes on this, so this should all be review. Hopefully what you're doing is just adding to notes you've already taken. If you weren't here and you weren't able to take them, well, just listen well this time. Your book starts with signs of a chemical reaction. There's certain things you can look for that let you know a chemical reaction is taking place. So we're going to look at signs of a chemical reaction. At this point, I would normally be doing demonstrations with you, but it's a little hard to do it from my kitchen. So, things you want to look for. If you look at other videos, you're likely to see that they're going to give you more examples than just these four. But these four are pretty typical. First thing you might look for is a color change. Lots of times this happens when you put acids and bases together and something called an indicator will change from pale or from clear to pink. When you tan, that's an example of a color change with a chemical reaction happening in your skin. The next thing you might see is the evolution of a gas. Okay, a gas is formed. Any of you who put baking soda together with vinegar when you were in middle school or grammar school, you saw a gas be formed. Okay, the whole thing just came whooshing out of the container. And you had a mess to clean up. But that's a gas being formed. The next thing is a temperature change. Temperature changes, it can be hot or things can get colder. You might think about just an ordinary fire. That's definitely a chemical reaction, definitely a fire, a temperature change. Another example would be a cold pack. If you've hurt your wrist or your ankle or something at a sporting event, likely a trainer has slapped a cold pack on you. So things can get hotter, things can get colder, but the temperature obviously changes. The last thing is the formation of a precipitate or a solid. Formation of a precipitate. Okay, a precipitate is a solid. And this is not a situation like water turning into ice and the water becomes solid. This is a situation where you have two liquids that are clear. One might be colored, but they're still clear liquids. You can see through them. You put them together and all of a sudden, boom, you've got a lot of solid forming at the bottom of those two liquids. Or it might look very milky and things will settle down to the bottom and then all of a sudden you see that solid. And if we were in the lab, I'd be showing it to you, but I can't. So, I'm sorry. Anyway, you're looking for those four things. You should know those four things for the test. Okay, next thing to talk about is what the heck is a chemical equation? Chemical equations can be written in various ways. Some of them are more useful than others. The first kind of chemical equation, which isn't terribly useful for doing any sort of work, is called a word equation. Now, a word equation is just that. You're using the names for the chemicals as opposed to the formulas for the chemicals. This uses nomenclature, that part of chapter 7 that you all loved so much. So, for instance, I could write down zinc reacts with, hydrochloric acid to form, that's kind of getting squished, zinc chloride plus hydrogen gas. Okay, so in case you can't read my horrible handwriting, zinc reacts with hydrochloric acid to form zinc chloride plus hydrogen gas. Okay, fabulous, right? It tells you absolutely no good. You can't work with it. You can't apply numbers to it. So what we would do is translate this to a formula equation. Okay, taking the same information, I would write down the formula for zinc. It's just an element, so we have Zn. It's going to react with hydrochloric acid, which is HCl, with a little AQ sign, meaning the hydrogen chloride has dissolved in water. You put an arrow, the arrow always points to the products, or the thing that's being made, and we form zinc chloride, ZnCl2, plus H2. Now, if you guys remember from nomenclature, I know that zinc is always +2, and the chloride ion is always -1, so that's how I knew the formula for zinc chloride. That's why we needed to do nomenclature first. Also, hydrogen is one of those 7 diatomic elements we talked about, so hydrogen, when it's by itself, always has to be shown as H2. Okay, these are reactants. That's what you're starting with. These are products. And the arrow can be read as yields, or produces, or makes, anything you want it to say, meaning I'm taking the stuff, putting it together, mixing it up, making the cookies, okay? The stuff you start with, the stuff you finish with. The problem with what I've written here is this equation isn't balanced. Balanced equations always have to follow what's called the law of conservation of mass. This means the mass of the reactants, or the number of grams of the reactant, have to equal the mass or the number of grams of the product. Okay, so we have grams reactant is going to equal the grams of the product. So to do that, we can't change any of the subscripts here because these compounds or elements are properly written. So the only thing we can do is add what's called a coefficient in front of something. Now, we're going to get back to this in a lot more detail later on, but let's just finish up with having this thing balanced. If you look up here, there's 1 zinc on this side of the reaction and 1 zinc on this side. Over here, there's 1 hydrogen, but there's 2 here. There's 1 chlorine, and there's 2 chlorines here. So somehow, without messing with these, we have to make the numbers of hydrogen and chlorine equal. So to do that, I'm going to rewrite that equation, zinc plus HCl. I'm going to leave out the AQ this time just to simplify what it looks like, making zinc chloride and hydrogen gas. Well, the zinc's fine the way it is. Okay, 1 zinc there, 1 zinc there, but I need 2 chlorines and I need 2 hydrogens. What if I put a 2 here? If I put the coefficient 2 here, it means take this whole thing and make there be 2 of them. So instead of 1 molecule of HCl, I have 2. Now if we count things up, we've got 1 zinc here, 2 hydrogens, 2 chlorines. If we go on the other side, we have 1 zinc, 2 chlorines, 2 hydrogens, and this equation is balanced. Now with a balanced equation, you can do calculations. It's obeyed the law of conservation of mass. You can use it in the lab to say if I have so many grams of zinc, I'm going to produce so many grams of zinc chloride. But to do all of that, your equation has to be balanced, and that's what we're going to do the next time. See you guys later. There's an assignment waiting for you.